1. Stop copying AWS reference architectures. They look great on paper, but they can be a trap for your project. I'll show you how to build a cloud architecture that truly fits your needs. When you blindly follow these templates, you risk creating systems that are difficult to maintain and scale. You might end up with services that don't talk to each other or that cost more than you can afford. 3. The simple explanation. Instead of copying reference architectures, focus on understanding the core principles behind them. Each component serves a specific purpose. Learn what you truly need for your application and build a flexible architecture that can adapt over time. What is the purpose of my application? Who are my users? What are my expected traffic loads? How do I want to scale? With these questions, you can start to create a tailored architecture that meets your needs. 4. Real-world example. Let's take a look at a startup called Quick Meal, which launched a meal delivery service. They initially copied an AWS reference architecture for a web application, which included multiple microservices, a load balancer, and a complex database setup. Their traffic was about 1,000 users per day, expecting to grow to 5,000 users within 6 months. They thought this architecture would make them scalable. However, they quickly ran into issues. The load balancer added latency. The database setup was too complex for their needs. They spent over $2,000 a month on services they never used. Realizing the mess, they decided to refocus. They simplified to a monolithic application, using a single database. As a result, their costs dropped to $800 a month, and they could handle their traffic without latency issues. 5. What to do instead. Here's a framework to build an effective cloud architecture without copying AWS reference architectures. Define your requirements, identify user needs and expected load. For example, if you expect 1,000 users, ensure your architecture can scale to 10,000. Choose your services wisely, start with essential services only. Use an EC2 instance for a simple web app, or consider AWS Lambda for serverless functions if you have unpredictable loads. Build for scalability, use auto-scaling groups to manage your EC2 instances. Set thresholds, for instance, scale up when CPU utilization exceeds 70%. Monitor and optimize, set up CloudWatch to monitor performance. Analyze logs to find bottlenecks and optimize resources. Iterate and adapt, after deployment, gather user feedback. Adjust your architecture based on actual usage rather than assumptions. 6. Common mistakes. Here are 5 common mistakes when designing cloud architectures, along with how to avoid them. Over-engineering. Avoid complex architectures for simple applications. Start small and scale your services as needed. Ignoring cost management. Don't assume all AWS services are affordable. Use the AWS pricing calculator to estimate costs before deployment. Failing to monitor. Neglecting to set up monitoring leads to blind spots. Always implement CloudWatch or a similar tool for real-time insights. Lack of flexibility. Building a rigid architecture makes future changes complicated. Design your system with modular components to allow easy updates. Following trends blindly. Just because a service is popular doesn't mean it's right for you. Evaluate if the service meets your specific needs before adopting it. 7. Quick checklist. Define user requirements and expected loads. Choose services that align with your needs. Implement auto-scaling and monitoring. Gather feedback post-launch. Iterate on the architecture based on real-world performance. 8. Summary plus CTA and summary. Stop copying AWS reference architectures blindly. Understand your specific needs and build a tailored solution. Focus on simplicity, monitor your system, and adapt as you grow. If you found this video helpful, drop a comment below and let me know your thoughts. Don't forget to subscribe for more practical tech insights. Bonus practical tip: if you're unsure what to pick, start with the simplest option that ships today. Then measure for 7 days, latency, errors, deploy time, and cost. Only upgrade when metrics force the decision, not fear.